Good morning to all. I am Dr. B. Perumal, Associate Professor in EEE Department from Adiyaman College of Engineering, Hosur. I did my doctorate at Anna University and my specialization alternating current to direct current converters. My teaching experience 20 plus years in this teaching field. Now, I am going to brief about synchronous motor and applications. So this is the introduction to synchronous motor. It is one of the AC machines. It rotates at a constant speed. That's why it's called as a synchronous motor. It's having some features, especially it operates at a constant speed, is nothing but synchronous speed, often used in high power and high efficiency applications. So this is the main features of synchronous motor. Next, I will talk about the principle of synchronous motor. The basic principle of this motor: the rotor of the synchronous motor rotates at the same speed as the rotating magnetic field produced by the stator. The rotor is magnetized either by permanent magnets or electromagnets. So this is the principle of synchronous motor. So this motor will rotate at a synchronous speed determined by the frequency of the alternating current supply and the number of poles of this motor. Using this formula, we represent Ns is synchronous speed is equal to 120F, that is constant, and frequency, the product of frequency and number of poles. Using this formula, this machine will rotate at a constant speed, that is synchronous speed. Next, I will talk about the construction of synchronous motor. So basically, the synchronous motor having two main parts. One is stator, another one rotor. The stator construction, it's made up of laminated sheets of silicon steel. It contains a three-phase winding that produces the rotating magnetic field. Using the laminated sheets, especially in this machine, will reduce the eddy current losses. So that's why we are using the laminated sheets in this machine. And also the stator will act as a stationary part. Next, the rotor construction. So normally the rotor having two types. One is salient pole type, that is projecting poles. The poles are projected out from the machines. So that's why we are called salient pole rotor. And non-salient pole rotor, so this is the another name, cylindrical rotor. The non-salient pole rotor will rotate irregular speed, but in case of salient pole rotor will rotate smooth speed. So generally we are using non-salient pole rotor in these machines. The rotor is excited by DC current to create a magnetic field. Especially these machines, AC supply we bring to stator windings. DC excitation will bring to rotor windings. The rotor will generate the magnetic flux. So that's why we have to connect the DC current to the rotor. Next, bearing and shaft. Inside of the rotor having supports the rotor and transmit mechanical power. The rotor acts as the outer frame and inner parts of the machines. The stator will act as the outer frame. It is supports to the mechanical support to these machines. So these are the construction of these machines. Next, we will going to discuss working of synchronous motor. So this is the construction as shown the figure. The parts of this machine: stator, rotor, field windings, stator windings, and three-phase supply. We have to connect the stator windings, DC excitation to connect the rotor windings. The rotor inside the center of the machines, the stator will act as the outer frame of these machines. The stator construction, the inner side of the stator, we have to cut the number of slots. In between the slots, we wound the windings. The windings is made up of copper. The slots and core is made up of cast iron or cast steel. The working of synchronous motor, we bring the three-phase supply to the stator windings. The stator will generate the alternating flux. In that flux will flows through all the stator windings nearly the speed of synchronous speed, and we send the excitation to the rotor windings. The rotor will generate the magnetic field. In that magnetic field and stator flux, when the north pole of stator flux and south pole of the rotor flux comes to each other, that is synchronized to each other, at this instant magnetic locking will occur. Due to the locking, rotor will rotate at a constant speed. That is, it will pick up to rotates at a constant speed. So that's why we are called the constant speed machines. The magnetic field generation, the stator creates a rotating magnetic field. When three-phase current flows through the stator windings, the rotor is powered by a DC supply, creating a constant magnetic field. So this is the function of rotor. Next, synchronous rotation. The rotor locks with the rotating magnetic field produced by the stator and rotates at a synchronous speed. The motor does not have a slip. So due to this, the rotor speed remains constant. So next, we go to discuss about the applications of synchronous motor. So the synchronous motor applicable to many places, many applications, especially power factor correction. So that is used in industrial plants to improve the power factor. Next application, large industrial drives, especially in pumps, compressors and mills. So this is the industrial applications of synchronous motor. Next, clock drives. It is applicable to the clock drives used in applications like time clocks because they maintain constant speed. Next, The main applications of this machine, synchronous condensers. It is used for voltage regulation in power system. So that is the synchronous condenser applications. Next, for this application of this synchronous motor, centrifugal pumps and fans. In this centrifugal pumps, this machine will run at a constant speed is required. So this is the main application of this synchronous motor. Power factor correction, large industrial drives, clock drives, synchronous condensers, centrifugal pumps and fans. So these are the applications of synchronous motor. Next, we go to discussed advantages of synchronous motors. So first one, constant speed operation. So ideal for applications required precise and consistent speed. Precise and consistent speed. No error of this speed. That's why we are called precise and consistent speed. Next advantage, power factor correction. It can be operated at a leading power factor, compensating for lagging power factor in this machines. Next, the advantages of this machine, high efficiency. More efficient at full load conditions compared to induction motors. Especially these machines, no slip. So, synchronous motors do not experience slip, providing more predictable performance. Next advantage, stability in grid. It provides stability to the power grid by maintaining synchronous operations. So, the main advantages of these machines, constant speed operation, power factor correction, high efficiency, no slip, stability in grid. These are the advantages of the motors. So finally we comes to conclusion. The synchronous motors play a crucial role in applications requiring constant speed and high efficiency. Despite their complexity and starting requirements, their ability to improve power factor and stabilize power systems makes them indispensable in certain industrial and commercial uses. So this is the conclusion of these machines. Thank you.